We just went over how to solve inequalities, linear inequalities, looked at putting things in interval notation, set builder notation, graphing on the number line or solution set. Now we're going to be looking at absolute value equations and absolute value inequalities and how to solve those. So hopefully after this portion of the lecture, you'll be able to solve equations involving inequalities or absolute values, and you'll be able to solve inequalities involving absolute values. So these, I am also using the notes that are with our textbook, just to kind of help and go a little faster, possibly. Okay, so recall the absolute value of a number is the distance from that number to 0 on the real number line. So the following. So first, verbally, what solving the absolute value of x equals 5 actually means based on the definition of the absolute value. Next, let's solve the equation, the absolute value of x equals 5, and show the solution graphically by graphing the absolute value of x and f of x equals 5 on the same axes. Well, if I have the absolute value of x is equal to 5, above it just said that was the distance between 0 and 5 on the number line. Well, the distance between 0 and 5 on the number line is 5. But there's another distance that gives us 5, which is the absolute value of -5. So the absolute value of 5, there's two values that would work, right? Either x can equal -5, because the absolute value of -5 still has the distance of 5 from 0 to -5 on the number line, or x could be equal to +5. So there's two solutions that work there. If we were to graph the absolute value of x, so if you need to, you can plot points. Let's just do that really quickly. So I know if I plug in 0, the absolute value of 0 is 0. So I have a point at 0, 0. I know if I plug in 1, absolute value of 1 is just itself 1. Absolute value of 2 is 2. If I plug in a negative number, the absolute value of -1 is +1. Absolute value of -2 is +2, etc. So I have this V-shaped graph for f of x equals the absolute value of x. If I was to graph f of x equals 5, notice there's no value of 5 in there. So whatever I plug in for x, my y value is always going to be 5. So if I plug in 1 for x, I get 5. 0 for x, I get 5. If I plug in 5 for x, I get 5. -5 for x, I get +5. So I technically have this horizontal line through y equals 5. So the solution are where these two values intersect. These two graphs intersect when x is -5 and when x is +5, which is the same solution as what we got when we solved it algebraically. On the next question says, solve for the absolute value of x is equal to -7. Well, we just talked about the absolute value of x was a distance between 0 and that number on the number line. It does not make sense to have a distance as being a negative result. And so solving for this, the absolute value of x equals -7. There's no solution. I cannot take an absolute value of a number and get back a positive result. So can there ever be one solution to an absolute value equation? Explain. Well, I'm not going to get any value, which is going to give me back a negative result when I take the absolute value. If I took the absolute value and my result was a positive number, a number bigger than 0, then I'm going to get 2 separate results. There is only one case I can think of that I would have the absolute value giving me back one solution. And that would be the case where I had the absolute value of x is equal to 0. Okay. So equations involving absolute values, if a is a positive real number, and if u is an algebraic expression, then we can say that the absolute value of u equals a is equivalent to u equals -a, or u is equal to positive a. So we're going to take what's inside the absolute value, and we're going to set it equal to the negative of the other side. And we're going to set what's inside the absolute value equal to the positive of the other side. And then we're going to solve. So when you're solving absolute value equations with one variable, so here are the process and the steps of doing so. So let u represent the algebraic expression inside the absolute value bars, and a be any positive real number. The other side is not a positive real number. If it's a negative number, we can just stop and say there's no solution. So first thing that you want to do, if you see an absolute value inside your equation that you're trying to solve, first thing that you want to do, if it's not already done so, is isolate the expression containing the absolute value so that you get something in the form of the absolute value of u is equal to our number a. So once you've isolated that absolute value sign, you're going to set what's inside the absolute value, u, equal to -a, and you're going to set what's inside the absolute value, which is u, equal to +a. Again, u is just the algebraic expression in the absolute value symbols. We're going to solve each equation once we've done that. And then we need to verify our solution to make sure our solution works. So for instance, we have the absolute value of c minus 15. And that absolute value, this is equal to 23. So our absolute value is already isolated. So we can set what's inside the absolute value, c minus 15. This is equal to -23. Or we have what's inside the absolute value, c minus 15 is equal to +23. So we want to solve each one of these equations for c. And so if we add 15 to both sides of the equal sign, on each equation, we would isolate c. So for our first equation, adding 15, we have c is equal to -23 plus 15. Okay, so -23 plus 15, I notice I have opposite signs. We got to subtract. 23 minus 15 is 8, but the larger number has a negative, so this is -8. Adding 15 to the other side of c minus 15 equals 23. We have 23 plus 15, which gives us 38. So we have two solutions here. And so we want to check and make sure our solutions work. So we're going back into our absolute value. And wherever we see a C, we're first going to plug in -8, and we're going to see, is this true? So if we plug in -8, minus 15 is the absolute value of that 23. So rules of absolute values, think of it as a parentheses inside that absolute value. So parentheses comes first before we take the absolute value. So we want to take the absolute value. First, we're going to sum -8 minus 15. So we get the absolute value of -23. Is this 23? Yes, absolute value of -23 is 23. So we also want to do it for if C is 38. So we have the absolute value. We're replacing C with 38 minus 15. Is this really 23? So simplify inside the absolute value first. 38 minus 15, that is 23. Is the absolute value of 23 equal to 23? And it is. So both of our solutions work. So notice it's okay for our solution to be negative, but it was not okay to start the equation where the absolute value is equal to a negative number. So we have two solutions for that in an absolute value equation. So our next example says solve the equation where we have the absolute value of 5 minus x and the absolute value, then plus 8 is equal to 1. So I want to isolate my absolute value. And so to isolate that absolute value on one side of the equal sign, we don't want that plus 8. And so we can get rid of the plus 8 by subtracting 8 on both sides of our equation. So we would get the absolute value of 5 minus x is equal to 1 minus 8, which is -7. I notice I have an absolute value equals a negative number, so I can stop, and I know that there is no solution. If you didn't see that and you had rewritten that as equal to the positive and the negative side and solved, when you had gone back to check, you would have seen that your answers did not work. Okay. So now we want to look at what happens if there's an inequality with our absolute value signs. So verbally describe what the absolute value of x less than 3 means based on the definition of the absolute value. Well, that's telling me that, remember that the definition of the absolute value was the distance between 0 and that number. Well, this is telling me that the distance between 0 and the number that I put in there has to be smaller than 3. If you're going to solve an equation with a less than sign and you have an absolute value, you want to sandwich it in between the negative of the one side and the positive of the other side. So when it asked us to solve this absolute value of x is less than 3, we're going to look at -3 is less than x is less than 3. So any number from -3 to 0, that is a distance of 3. And any number from 0 to 3, not including 3 or -3, that distance is also less than 3 to 0 on the number line. So our set builder notation, set, so curly bracket X, vertical line, such that X is between -3 and 3. Interval notation, I have a parentheses, -3, comma 3. So if you have inequalities in the form of less than or equal to, and we're given that the value on the other side of the inequality is a positive value. So if A is a positive real number and U represents the algebraic expression, we can say that the absolute value of U is less than A is equivalent to -A is less than the algebraic expression U, which is less than A. If it has the equal to part with that inequality, so the absolute value of U is less than or equal to A, then to drop that absolute value, you're going to look at -A is less than or equal to the algebraic expression U is less than or equal to positive A. So I had mentioned earlier in class when we were looking at solving inequalities that we can break this up into 2 different inequalities. So in other words, the absolute value of U is less than A. We can say that U is greater than -A and U is less than positive A. So solving the following, we have the absolute value of X minus 15 is less than 23. So I can break this down as -23 is less than what's inside my absolute value. X minus 15 is less than 23. So let's get X by itself in between the 2 inequalities. And so if we add 15 to all sides, we would get here that -23 plus 15 is -8 is less than X, which is less than 23 plus 15, which is 30. So express your solution using set builder notation, interval notation, and graph your solution set. So set builder notation is pretty much exactly what we wrote, except we have that curly bracket X, vertical line such that -8 is less than X is less than 38. And our curly bracket. Interval notation, we're starting at -8, not including, so we have a parentheses, -8, comma, and then we're going to 38, not including, so parentheses. We're looking at all numbers ranging from -8 to +38, but we're not including those values, and so we have parentheses on each side of the n values of our inequality, and then we have everything shaded in between. So that was if you have less than sign with the absolute value. If we have greater than sign, so for instance, if we verbally want to describe what the absolute value of X is greater than 4 actually means based off of the definition of the absolute value. So that's telling me my distance between 0 and the number we choose. That distance has to be bigger than 4. So any number that I choose that is bigger than 4 is going to work. So I can say that X is either going to be bigger than 4, or if we choose any number that's smaller than -4, then that would also have a distance to the number, to 0 on the number line of 4 or larger. So x either has to be bigger than 4 or x has to be less than -4 for the absolute value of x to be bigger than 4. That's basically how we're going to put that when we solve it. So x greater than 4 or x less than -4. In set builder notation, so set x such that x is bigger than 4 or x is less than -4. If we were to look at that in interval notation, let's start with the smaller. So x is less than -4. So that's coming in from -infinity, getting very close to -4 on the left-hand side. So write -4 and then parentheses. Union, which means this set or this set, they both work. We could have a number close to 4 on the right. So parentheses 4, comma, infinity, into parentheses. So graphing it, we're shading everything to the left of -4 and putting a parentheses on -4. We're shading everything to the right of +4. So parentheses on the 4 and then shade everything to the right. So anything that falls in that shaded region that's not the end value of the inequality would make that a true statement. So in other words, if you are looking at an inequality and you have a greater than or equal signs involving absolute values, we're going to say that our value A is a positive number. We're saying that U represents some algebraic expression, which is inside the absolute value. The absolute value of U is greater than A is equivalent to saying that U is less than -A or U is greater than A. Only difference is for the next one, the absolute value of U is greater than or equal to A. It's equivalent to U is less than or equal to -A, or U is greater than or equal to +A. Looking at the next example that deals with an absolute value with a greater sign in there. So solve the inequality. The absolute value of -2x + 1 is greater than or equal to 9. We want to express our solution using set builder notation and interval notation, and we want to graph our solution set. Okay, it's a greater than or equal to, so I'm going to rewrite it as two separate inequalities. We're going to take what's inside the absolute value, which is -2x + 1. And this is going to be less than or equal to the negative of the other side, -9. Or we're going to take what's inside the absolute value, -2x + 1. And we know that this has to be greater than or equal to 9. So solving each one of these inequalities separately. So we want to get x by itself on the left-hand side. So for the first inequality, let's subtract 1 on both sides. We get -2x is less than or equal to -9 - 1 is -10. We want to get x by itself. We're dividing by a negative number or multiplying by -1/2. We're dividing by -2. If we do that, though, that flips our inequality sign because we're dividing by a negative. So I get x is greater than a negative divided by a negative is positive. So negative 10 divided by negative 2 is positive 5. X is greater than or equal to 5. The other example, we want to get x by itself. Equation, inequality. So again, you're going to subtract 1 on both sides. We get negative 2x is greater than or equal to 9 minus 1, which is 8. Again, I'm going to divide by a negative, so I want to flip my inequality sign. So if I divide both sides by negative 2, we get that x is less than or equal to negative 4. So set builder notation is x such that x is less than or equal to negative 4, or x is greater than or equal to 5. To write that in interval notation, I'm looking at coming in from negative infinity up to negative 4. I'm including it, so bracket. Union. Now I'm also taking the set, starting at 5, including it, so bracket 5, comma, going to infinity. Locate negative 4 and 5 on the number line. We're looking at everything to the left of negative 4, including negative 4, so a bracket there. And starting at 5, including, so bracket on 5, and everything bigger than, so shade to the right. So another example with a greater than, or in this case, greater than or equal sign, we have the absolute value of negative w plus 3 minus 5 is greater than or equal to 2. So I want to isolate my absolute value to one side of the equation. And so I notice I have a minus 5 on that left-hand side outside of the absolute value. So I don't want that minus 5 there, but I can get rid of it by adding 5 to both sides of the inequality. If we do that, we have the absolute value of negative w plus 3, and the absolute value is greater than or equal to 2 plus 5, which is 7. We've isolated the absolute value, so we want to drop the absolute values and rewrite it. So this is a greater than, so if values which are greater than 7 on the number line, that distance from that absolute value. So that would be numbers, so negative w plus 3. What's inside the absolute value is less than or equal to the negative 7, or what's inside the absolute value, negative w plus 3, is greater than or equal to 7. So solve for w in each case. First case scenario, to get 3, not on the left-hand side. To undo the addition, we would subtract 3, and we would get negative w is less than or equal to negative 10. We want to divide by a negative number. So we're dividing by a negative or multiplying by a negative. That flips my inequality. And we get w is greater than or equal to, well, negative 10 divided by negative 1 is positive 10. Or solving for w in the other equation, again, we want to get w by itself. So let's subtract 3 on both sides. We get negative w is greater than or equal to 7 minus 3, which is 4. We want to divide by a negative sign, so that's going to flip our inequality. Dividing through by negative 1, we get w, negative w divided by negative 1 is positive w, and 4 divided by negative 1 is negative 4. So set builder notation, we got w such that our w is less than or equal to negative 4, or w is greater than or equal to 10. So interval notation, I'm looking at everything coming from negative infinity, going up to -4 with a bracket. Union, I'm looking at everything from 10, including 10, so bracket 10 to infinity. So graphing our solution, locating -4 and 8 on your number line. You're looking at everything less than -4, so shading to the left of -4, but we're including it, so bracket. I don't know why I said 8, but it's 10. And then we're looking at everything bigger than 10 and including 10, so bracket at 10 and shade everything to the right of 10. Okay, so there was a question about that U symbol. And this symbol U is actually means this is the union of two sets. So when we're looking at the union of two sets, we're looking at what's in one set plus everything that's in the other set. And this is an or statement. So the solution is in either set. Okay, so let's look at one more example. This is something similar to what you might see in a calculus course. And so you're given a bit of information. You're saying that if you're given this absolute value of x plus 2, let's say it is less than 5, then the following is true. A is less than x minus 2 is less than b. And in the directions, it asked us to find A and B. Okay, so we're going to look at what we're given. The absolute value of x plus 2 is less than 5. What we're going to be trying to do is we're going to be trying to manipulate, once we rewrite this without the absolute value, we're going to try to manipulate what's inside the two inequalities to look like this x minus 2. Okay, so in order to drop the absolute value, we're taking what's inside the absolute value, x plus 2, and we're sandwiching in between -5 and +5. So I want to manipulate this so it's x minus 2 in between both of those inequality symbols. Well, so I don't want +2 there, I want -2. So I can either do a couple things. I could subtract 2 on both sides and get x by itself. That helps you, you can do that. So whatever I do in between the inequalities, I have to do on each side of the inequalities. And so subtracting 2 on both sides, I would get -7 is less than x is less than 3. But I wanted x minus 2, not just x in between. And so if I subtract 2 on all sides of our inequalities, I would have -7 minus 2 is -9 is less than, well, x minus 2, those aren't like terms, so we're going to just write it as x minus 2, is less than 3 minus 2, which is 1. So once we've gotten what's in between the two inequalities to what we want it to, we can figure out what A and B are. So I notice here that my A value has to be -9. And here my B value is equal to 1. So one more, let's look at one more similar to what we just did. So this time we're given that if x minus 3, so absolute value of x minus 3 is less than or equal to 1, then we're given that A is less than or equal to 3x plus 1, which is less than or equal to B. So if this is true, then we want to find A and B. Okay, so let's drop our absolute values for that if statement, and then let's go through and manipulate what's in between our two absolute values once we do that to look like 3x plus 1. So to drop the absolute value less than sign, we would have -1 is less than or equal to what's inside the absolute value, x minus 3, is less than or equal to 1. So I want to manipulate what's inside here, this x minus 3, to actually be 3x plus 1. So let's get x by itself first. So to get x by itself first, we can add 3 to all sides of our inequality. So we get 2 is less than or equal to x is less than or equal to 4. I want it to be 3 times x. And so remember, it's okay if we multiply by a positive. That's not going to change our inequality, the direction of our inequality. So we could go through and multiply everything through by 3. So I have 3 times 2 is 6, is less than or equal to 3x, is less than or equal to 12. So I have the 3x in between, but I want 3x plus 1. So we can get that plus 1 by adding 1 to all sides of our inequality. So 6 plus 1 is 7, is less than or equal to, well, 3x plus 1, they're not like terms, so we're just going to write it as the sum, is less than or equal to 12 plus 1, which is 13. So in this case, A has to be 7, and B would have to equal 13. Okay. So that was a section on solving absolute value equations and absolute value inequalities.